Okay, welcome everybody to the first Digital Transformation for the Steel Industry webinar. This is the first out of the 10 scheduled digital transformation webinars organized during the summer between May and August timeframe. My name is Alicia Gaffin and I am the staff engineer for the Digitalization Applications Technology Committee here at the Association for Iron and Steel Technology. Before we start the webinar, I would like to go through some important reminders for the attendees. So I would like to mention that the attendees' audio has been disabled, so you will not be able to speak during this seminar. However, questions to the presenter can be submitted via the chat. And the host and the moderator will at the end determine which questions to present for the presenter. I would also like to inform that this session is being recorded and it will be available 2 to 3 days after the webinar on our AIST's website. If you have any technical difficulties, please don't hesitate to contact me. Photos or recordings of presentations is strictly prohibited. You will be given a link to access the presenter approved presentations and recording following the end of the webinar. I also want to present to you the AIST anti-trust guidelines, which emphasizes the law that prohibits agreements between individuals to regulate prices and to hinder or limit competitors. I also want to brief you on the AIST anti-harassment policy, which emphasizes the importance to provide a harassment-free environment, regardless of age, race, disability, or gender. I would also like to thank the sponsors for today's webinar, which is SMS Group and Noodle.ai. And SMS Group is a reliable partner in plant and mechanical engineering for the industrial production and processing of iron and steel and non-ferrous metals. SMS Group offers integrated solutions for metallurgical process technology, casting and rolling technology, as well as for other forming and finishing processes, including the respective electrics and automation solutions and services. SMS Group Digital Unit offers data platform solutions, sophisticated digital products, machine learning and consulting services, focusing on asset health, product quality, production planning, and energy management in the metals industry. The introduction of Noodle.ai applies advanced data science to create a world without waste. And with Noodle.ai's advanced enterprise AI applications, business leaders are empowered to make better decisions, reduce wasted energy, money, and resources. Noodle.ai offers radical efficiency to manufacturers and supply chains using leading-edge artificial intelligence. Noodle.ai is leading provider of AI applications in the steel industry and a thought leader in the digitalization of the steel industry. Thank you very much to the sponsors. And thank you very much to the attendees for attending this webinar. I would also like to present the moderator for the webinar today, which is Michael Dudzic. Michael Dudzic was first a consultant at ArcelorMittal Dofasco GP before joining the company full-time in 1987 in process automation. Since then, he has had various leadership roles in process automation, moving to a general manager, process automation in 2005, and most recently to a special assigned overseeing the company's digitalization transformation. Dudzic has been involved in various advanced model and control projects throughout manufacturing and is the co-inventor of 3 ArcelorMittal Dofasco patents. He has been involved with the Industry 4.0 and digitalization technology since 2015 and has participated in the Advanced Control Consortium at McMaster University and AIST's Digitalization Applications Technology Committee. Now I would like to give the word over to our moderator here, Mike Dudzic.
Thank you, Alicia. So thank you, everyone. Welcome. So my name, Mike Dudzic. I was one of the co-sponsors of the Digital Transformation Forum and on the core committee there. We're very sad to see that we weren't able to make it due to the crisis. However, we're very pleased that we were able to get the presentations through this webinar view. Our first presentation was really one of our keynotes between Noodle.ai and SMS. And now you see that we've done it over a two-day series there. So we're very excited about it there. We're really interested to kick this off with two very good presentations. The first one today is Steve Pratt, is the founder and chief executive officer, CEO of Noodle.ai. Prior to Noodle.ai, he was responsible for all implementations of Watson worldwide for IBM Global Business Services. His leadership as founder and CEO of Infosys Consulting is taught in case studies written by Stanford and Dartmouth Business Schools. He grew Infosys Consulting from a startup to more than 30,000 people. Prior to Infosys, Pratt was a senior partner at Deloitte Consulting. His career began doing classified projects in the intelligence community, focused on many interesting and exotic things, especially in the use of AI there. Before we proceed, I just wanted to mention that the way we're doing it this time is that we're going to be Steve will be providing a portion of the keynote presentation. Katja Wynn from SMS tomorrow will be doing the second part of it there. We had various questions from our attendees for the forum there, and we asked Steve and Katja to take a look at some of those questions and provide those questions, some answers to those questions there. So this was a good opportunity for some of the key questions to be provided to you during this keynote address here. So we'll have a few questions that I'll be providing to Steve, as well as if you have any questions you want answered. If we have some time remaining, we'll go to 5 minutes before the end of the hour. If you could put them in the chat, and we'll try to select a few, timing pending here. So we look forward to this presentation. So Steve, take it away.
All right, thank you very much, Michael. Let me, you could unshare, then I'll share. I think somebody needs to unshare, please. Perfect, thank you. Okay, hi everybody. During normal times, people talk about that a rising tide lifts all boats. But I think what we're seeing today is that a lowering tide exposes rocks. And that's what I'm going to talk about today is maybe some ideas on how to navigate these rocks. And the real challenge that I think that everyone's focusing on is how do we produce profitable steel at $450 per ton for HRC and obviously the corresponding price point for other metals products. And what I'll talk about today is some ideas on how to get there, or at least to get a lot closer to there. So when you talk about the levers that everybody has in getting to profitability at $450 a ton, there are things in the physical plant, and then there are things in digital infrastructure and operations. A lot of things on the physical side are, as you know, very capital intensive and take a very, very long time. Things about production methods, innovation and metallurgy, plant consolidation, just higher margin production lines of doing fewer products that are more profitable. What I'll talk about today, however, is things that I think are less capital intensive and faster, and also have dramatic value potential within your plants around downtime, maintenance cost, quality yield, cost of raw materials, and just better scheduling to get a higher profit per mill hour. And specifically, what I want to talk about today and the areas in which we focus are machine learning and AI that we are seeing in action as a breakthrough technology to enable profitable steel mills at much lower prices per ton. These AI applications are in production and getting exceptional results. And then I'll also talk about a caution that there's a lot of AI snake oil being sold out there, and just some ways that you can sort of filter out what is real and what is not real. And so what I'll talk about first of all is we have many of our applications in production in the steel industry, or in the metals industry more broadly, but a lot in steel also. I'll just talk about today as just an intro, a $10 billion plus global steel producer, where we have two applications that are up and running. One in asset health, which does anomaly detection and remaining life prediction for the mill. This is across the casters, hot rolling, cold rolling, galvanizing lines, and then also product quality AI, which has real breakthroughs in quality maintenance. And the results that we're getting are increased uptime in the plant, lower maintenance costs, increased quality yield. And we're seeing about a 30% reduction in downtime across these plants and assets. And we're happy to go into more detail of this offline. Obviously, we need to protect confidentiality of customers. But I can tell you that when we talk about this, that we get a lot of people who say, "I don't believe it." One of my favorite paintings that I own is in the upper right-hand corner, and it's called "The Skeptic." And so I think being from the Midwest and Central Illinois, sort of I'm a very practical person. I understand skepticism, and I'm naturally skeptical myself. So what I thought I would do today is kind of give you a peek under the hood and to show you how this is done and why it can get such a breakthrough in these areas of running mills. So first, to frame the problem with legacy software, specifically for maintenance and quality in mills, is that your current systems are giving you many false positives and many false negatives. False positives saying that it says there's a problem, or it says there's going to be a quality issue, but there's not, and a lot of time spent in chasing ghosts. And there's also many false negatives of things that went wrong that you didn't see coming, resulting in quality issues that aren't explained or very, very hard to explain, and unplanned downtime. And this is a lot of money. If you look at it per ton, this is about $26 million in costs per year that are from these issues. So typically about $13 million in quality downgrades, 10 million in unplanned downtime, 3 million in over maintenance per year. So let me talk about the difference between the approach that legacy software takes and how AI can get such dramatic improvements. So here's how the current systems work, is you get sensors that are coming off of a portion of your mill. And the way the systems work is they set thresholds. And they say, if the reading on the sensor goes above a certain threshold or below a certain threshold, it sets an alarm. And for those of you who have been in plant operations, and I'm sure many of you have, that you realize this is a very, very frequent thing, sometimes hundreds, sometimes thousands of alerts per day across a mill. And a lot of these are false positives, but there's also a lot of false negatives of things that you should be paying attention to, that this very, very simple approach does not catch. So how is AI and machine learning different than this approach? Well, the first thing it does is it doesn't use thresholds. What it does is it actually analyzes the shape of the waveform that comes off of the sensor. So if you have a leaky valve, for instance, it may not exceed any thresholds, but the shape of the waveform coming off of that sensor will look anomalous, and it will be able to tell you things that are anomalous that a simple threshold-based system can't do. And it analyzes these waveforms across about 15,000 signals per line in a mill. So that's just the first level. The second level is what it does is it does what's called multivariate correlation. Is it looks at, for these 15,000 data streams that are coming off of a traditional mill, that it looks at the combinations of waveforms over time. So it says, when this waveform is like this, and this waveform is like this, and this waveform is like this, that it's likely that you're going to have a quality issue. And it looks at various time windows for each of these what are called states of each of these data streams, and looks at combinations of over 100 million data stream, or the 100 million combinations of data streams per timestamp. So very, very sophisticated analysis that identifies quality issues that simple threshold-based systems cannot detect. And then it takes it one step further computationally, and it says, not only do we look at the waveform and the combinations of waveforms, but it says it looks at what combinations of waveforms under what contexts are anomalous, either leading to a quality issue or unplanned downtime in a mill. And some of the contexts that are input into our models are what kind of steel is being made, what's the weather, who's running the plant, what scrap is being used, what transitions have occurred from maybe gauge or width or chemistry, and what's the condition of the equipment. All of these things are very, very important for predicting quality issues that obviously threshold-based systems just cannot do. The other thing is that these systems then look at not only what's happened in the past, like traditional systems. Legacy software basically is the current time and what's happened in the past. But obviously that doesn't help you very much in looking into the future, other than just using gut feel and experience from operators. So what this does is actually look at, it uses historical data and learns how the mill is operating and learns the physics of the mill. And then it predicts into the future when you are likely to have an issue. They'll say how likely a quality issue is, how likely a maintenance issue is, when it is likely to happen, and what is the best action to take. And then really good AI, and what we've been able to do is to not only say what is likely to happen, but why will this happen, right? A lot of AI suffers from black box syndrome. So it takes a lot of effort to get to a glass box to explain why something will happen. So for instance, it could say that you're going to have a quality issue because the chemistry, because you have this chemistry, you have this force, you have this mill speed, you have this condition of these events, and it's this temperature, and this crew is operating the mill. It's all of these things together that are much, much better at predicting what is going to happen in your mill. So this is a really hard thing to do. To actually pull this off, you have to analyze about 71 trillion data points per line to train these models, and then to take and do all of these analyses in real time as the data is coming off the mill. And so this is something that was simply not doable. Certainly 20 years ago, this was an impossible thing to do. No matter how much money you had, the fastest supercomputers in the world could not achieve this. The the evolution in computing power, the reduction in the cost of data storage have created this breakthrough in the ability to analyze these massive amounts of data and to come up with these very, very sophisticated applications that can work incredibly well. And I'll just note that the 71 trillion data points is just in the hot mill. So if you go to the other parts of the mill, it gets even more complex. The other thing that I think that is exciting to us is that the people who really, really like these applications are the most experienced operators in the mill. That people who've been spending their careers, decades running mills, understand intuitively. They have rules of thumb. They've done mental calculations. They know what looks wrong, what sounds wrong, what even smells wrong, what feels wrong, and they have intuition. And what this does is actually to confirm that intuition. It quantifies that intuition, and the combination of these very powerful analytic techniques and experienced operators is really how you get the best outputs out of your mill. So a lot of people are selling AI or things under the banner of AI. You know, Gartner predicts that 85% of all AI projects won't deliver. I'll just underscore the word projects there. AI should not be a project, right? It should be an infrastructure upgrade to your system, right? So the types of snake oil that are out there, there are 5 common ones. There's the miracle platform that you just put in this platform and then magically you can create all these AI applications. There's the toolkit, which is, it's almost built. It's just like an IKEA, right? It's like building an IKEA Hoover Dam or something, right? That you just assemble it at home. There's the, we'll help you do it yourself, right? And promise to turn it over to you someday. And then tens of millions of dollars later, you realize that this isn't working. They're the people who are saying that steel is just like any other industry and it's easy. And then probably the most prevalent is the roadmap, where we'll come in or somebody will come in and say, we're going to map your pain points by value and by complexity, and then you should start custom developing these 10 AI applications, starting with a blinking cursor. And I can tell you, having invested over $50 million in developing our products, that AI applications are temperamental and don't always work, right? It follows the scientific method of hypothesis test, and you have to make sure you have the right models, the right data, the right way of working things for these to succeed. So how do you tell, right? And if something is snake oil or not? I would say there are really 5 questions. First of all, is this a project or is this a product, right? That we're implementing. I would say, like, show me the data model. What data are you using? Show me that data science approach that you're using for this that's proven. How long is it until I see value? I would say that a metric for how long it should take to see value is that once all the data streams are connected, if it takes more than a couple months to get the application up and running, that it's more likely a project than a product. It does take time to connect all the data streams. That's typically, I would say, 2 to 3 months to connect the data streams. But once they're connected, the model should work fairly quickly. And when you're analyzing investments, like what are the other costs other than just the project itself? What tech stack do you need? What other people investments do you need? Is really, really important. So avoiding snake oil. So what should you do, right? I would say, first of all, I think it's important to get started and to learn. I think this is a real breakthrough in the metals industry and represents the future of high profitability and in these very tough times of profitability. don't throw out any data, your historic sensor data, your historic quality logs. Make sure that you are keeping good quality logs. These are the training data for the applications, and make all the difference in the world. This is really, really valuable information, and with today's technology is affordable to store. Please release your data and put it to work. Right now, a lot of you store your data in IBA, what is organized by small time sequences. You can't query the data. It's very tough to do root cause analysis. Please implement technologies that can help you query IBA data. I would say pilot a proven AI application in one mill or one line, and see the results, and then scale it. I would build this into your budgets. I would make sure that you hold operators accountable for the financial results and the operating results. And please don't try to custom build AI applications, right? I've been around long enough to see this in many waves of technology over time, is that a lot of customers try to custom build things, and it just ends in many, many years of frustration, and basically saying, I mean, a long time ago, like CRM isn't very good because we custom built our CRM application, and then eventually they throw it out after spending tens of millions of dollars and then just buy an off-the-shelf software. So please do that. Finally, I'd like to give a shout out to what I call the magic combination. It's the team at Noodle.ai and our amazing product teams and data scientists, our really good partner SMS, who brings equipment, physics, and digital expertise, and really the leaders and the operators of our customers who are, I think, forging this new, really bright future for the steel industry, one that can survive the downturns and accelerate out of them, and really chart a very, very profitable future for this industry. So thank you very much, and happy to take questions.
Okay, thank you very much, Steve. Yeah, we have a few questions that we provided. These were ones that I mentioned earlier that were provided as attendees to the forum there. Also, I mentioned that I challenged Steve with the current steel industry crisis and what could we be doing with digitalizations there. So if you can go to the next page. So the first question is, what are some of the challenges you have encountered with industrializing AI machine learning applications like asset health, product quality into plant operations there? So you talked a little bit about that. How did you overcome the challenges there? So I hear from many people, it's really that, yeah, they piloted, but the industrialization was really challenging there. Any comments you want to provide there?
Yeah, well, thank you, Michael. I mean, there are many, many challenges along the way. I mean, in getting to a final product that is industrial strength and works. The first challenge is, and I alluded to this a little bit, is that developing AI applications is very different than developing traditional software. With traditional software, you write a specification and then you write the code, and then it does exactly that. Good or bad, it does exactly that. With artificial intelligence and machine learning, you take a massive amount of data, you run an algorithm around it, and you see what you get. See if there's anything of value that comes out the other side. And a lot of times it doesn't work, right? That the stuff you get out the other side, either it doesn't find the right correlations or the right predictions, or it's not of value, not something you can act on. So first of all, I think running many experiments to come up with something that actually works is really important. That's why I think unless a company really wants to be an R&D shop and run a lot of very, very expensive experiments and spend a lot of money, you should probably let other companies make that expenditure, and software companies do that. the other part that is difficult in industrializing it is to make sure that all the data pipelines get connected. This is just something that is a reality and takes a while to harden those and to make sure that they are up and running constantly. It takes very sophisticated tech stack to make sure the data is high quality and it keeps up and running. And then the third one is user adoption, that coming out with a data science model that is incomprehensible to operators won't work. So there's also this translation of very sophisticated mathematics to something that an operator under a lot of pressure every day can really understand. So I'd say those are the main challenges.
Great. Thank you very much. Let's go to the second question here. So this is also another one that's really interesting that was provided by a panelist, and we tweaked it a little bit there because one of the attendees was really interested in highest ROI there. So, you know,
yeah.
Wanted to ask Steve, what did that look like there? But we also wanted to highlight that in this current crisis, the highest, if it's a lot of cost, a lot of time, may be a challenge there. Also want to see what might be the fastest way of getting ROI. What may be those low-hanging fruits that with a little bit of investment, a little bit of time, could really get some real value and get the ball rolling there. So Steve.
Right. Yeah, so it's a very good question. And I would say the fastest is probably not the highest. So I would say the fastest way to get ROI on this is to look at asset health, specifically anomaly detection and remaining life analysis. It is the thing that is the fastest to do, has a very positive ROI, and will basically get rid of a lot of this unplanned downtime because it'll give you much better information. Then adding on to that, which is actually a very fast thing to add on top of that, is product quality. It uses the same product, it uses the same pipelines and everything. It just does, it switches from something called unsupervised learning to supervised learning, which actually correlates quality events to basically the same data. And so that's you know, that you do the hard work of putting in the data pipelines, you get anomaly detection very quickly, remaining life, then you go to product quality, which is a pretty fast and significant ROI jump. I would say from a highest ROI perspective, there's another aspect of this, which is materials mix, which has dramatic improvements in your cost of raw materials. So looking at what's the optimal combination of, if it's an EAF, scrap, or depending on what other types of mills or furnaces or products you're making, what kinds of materials do you need to go into there? Most of those systems right now are not cost optimized. So I think that's an important one. And then finally, sort of the pinnacle of it is scheduling. For scheduling for profit per mill hour. That is something that takes quite a long time to do because every mill is very different and all the permutations are very, very different, but also has very, very high ROI. So I would sort of start with, you know, asset health, product quality, materials mix, and then scheduling if I were to lay out that path.
That's really good. Thank you very much. You gave us a good view of many different areas there. And I know, yeah, when you start getting into quality, materials, scheduling, these are some of the biggest challenging problems there, but appreciate also, you know, some of these smaller ones that can at least get people up and running, seeing some real positive value there. Okay, we'll go to the next question here. So, yeah, this was also one that I challenged Steve here, and he took me up on his offer there. So I said, we know that our audience is comprised of people with a range of experience and readiness for digitalization of their mills. How would you suggest someone get started, especially under these current crisis economic conditions being felt by the steel industry?
Yeah, so I mean, I think that the key to investment and during the crisis is to get an economic return within the budgeting cycle, and something that does not require a huge cash expenditure, because cash management is critically important, and also making sure that from an income statement point of view, assuming it's expensed, that you get a return within the budgeting cycle. And so that gets you into the asset health, product quality area. Some of these other things will take longer and probably go outside of a budgeting cycle. So I would start small. I would go just to prove it, and to get used to how this works. So I would start with maybe even one line in one mill and do asset health and product quality, right? And I think it's something that will get a return within the budgeting cycle, and is something that that is it's a proven approach. It works. The financial results are, unless your mill is completely different than any other mill in the world, you will get very solid economic return in a predictable amount of time, and that's how I would start. There's also other things around economic agreements with companies like ours about shared investment. So we're willing to do that. And so I think there's a lot of things that people can do to make sure that that we navigate this. I will say that I often look at the Formula One analogy of, you're going into a turn. First of all, most of the passing of cars happens in the turns, and coming into the turn, you need to know when to brake, how much to brake, and then very importantly, you need to understand how to accelerate out of a turn. And so I think putting in some of these applications from a digital perspective that can help you accelerate out of this turn, and to if you can perform profitably at very low prices for your products, that as you come out, you can really thrive in this area. And but I do understand that there's a huge cash crunch in a lot of companies, and so I mean I'm we're very well aware of the issues that are going on. And I would say that if you're looking at physical plant upgrades, those are incredibly expensive things, as you know. And I think this is a much faster way to do it. It's untapped potential in a lot of mills, and it's something that will, I think, provide a much higher return per dollar of investment than those other areas.
Great, thank you, Steve. So those were all the questions that we predefined there, and like I indicated before, these were ones that were very popular with the attendees to the forum. Now, we do have some time here. We have another 10 or 11 minutes. We've been getting inundated with lots and lots of questions here. Alicia, just wanting to check, is Ram the first question you'd like?
Yes, so the first question would be from Ram K. Kondapi.
Okay, so yeah, we have a good number here, Steve. We'll go through, and you can get through as many as we can in the next 10 minutes. So Ram asks, does digital data collection and analytics precede or feed into AI applications? How does one justify associated project costs up front to proceed with projects?
Yeah, so I mean, analytics is sort of a umbrella term for all of this. That I mean, I'll just tell you specifically the data sources that are used for AI applications in a lot of any analysis would be, you know, there's all the way from L0 to L4 data within your systems. Typically, when you're looking at asset health and product quality, it's lower level sensor data combined with external data and combined with quality logs. And it's doing the very complex mathematics around all of those. A lot of that is what's being analyzed also for traditional. Well, BI typically is, first of all, BI analysis is typically backwards looking and at much higher levels. It's not looking at, you know, raw sensor data. It's not looking at trillions of data points. It's basically providing, you know, it's a report. It's reporting basically. So I would say that the difference is AI would use a lot more of the lower level data within the company.
Okay, thanks, Steve. The next question was from Marta. If not using a threshold to define what is an anomaly and based on waveform shape, do you follow a supervised approach? And then, like otherwise, what do you use to find these small pieces and know that they are related with anomalies there? So it's really this whole new approach here. Maybe you could explain a little bit more. Yeah,
it's a really good question, and somebody who understands data science a little. Or a lot, right? So the anomaly detection part and the remaining life parts of our applications are unsupervised, meaning that well, supervised is, it says, has what's called a labeled event. So it's like how a computer recognizes a picture of a cat. It shows it a bunch of pictures of cats, and then it eventually learns what a cat is. Unsupervised learning is it gives you a bunch of data, and you have to identify what's wrong in this data. And so what it does is it takes about 2 years of history, and it learns what is normal. It learns transition states for each data waveform. So for instance, I gave the example of a pump earlier. It would say the pump has 4 states. It has pump closed, pump opening, pump open, pump closing. And it would identify the time windows associated with each of those states and what is normal. And then it would see a pump that is not operating normally, and would say that that is anomalous. It also does this across multiple assets within the factory, and will say that if that pump is doing that, and the flow is at this rate, and the pressure is at this rate, then that combination is anomalous, and it does that level of mathematics.
Okay, thank you, Steve. Yeah, the questions keep coming in, so we still got another 10 minutes. So here's a longer one here, but let me read it all out. This is from Jim. How do you ensure the network has the bandwidth to analyze 71 million data points live? I don't know any steel mill with this type of bandwidth as that is bandwidth along the lines of what a large online company like Amazon would need. Most of our mills have just gotten to 1 gigabyte Ethernet with 1 gigabyte backhauls, and a few just now starting to upgrade the backhauls between switches to 10 gigabytes there. Yeah. Even worse, IT departments usually don't focus on the process side. Usually the process side of the network has even lower bandwidth than the business email side. So obviously someone who's worked in the IT side and is dealing with bandwidth issues there. And yeah, this is definitely a challenge that we're all seeing. Comments?
Right. Yeah. Good. Very good question. I should, and certainly if you were trying to do 71 trillion data points in real time, that would be a big issue and probably not practical. the 71 trillion data points is the training data for the application. So it is actually sent in batch. And there's a lot of different ways of doing that. It could actually be in physical storage. Sometimes the amount of data that needs to get transferred is so large, it's not practical to send it over digital connections. And so there are things called snowballs or other things that actually transfer data in a highly secure encrypted way. And so those are the data that are used to train the applications. So, and that's what is incredibly computationally intensive. So that's usually an infrequent thing. It's required to train the applications up front so that it learns and understands the mill. And then the live data that is done on a continual basis is a much smaller. What it does is it finds what are called the features, which are the important things, and what it does is it transfers just those data on a regular basis. So we also have not to get into too much tech talk, but there are edge devices that actually have some level of AI at the edge that understands what data is important and interesting and what data is not interesting, and adjust the sampling rate and the transfer of the data to storage and to be analyzed. It would be analogous to, if you had a security camera at your home and it's 3 o'clock in the morning and nothing's going on, then it's not interesting data because nothing's going on. If it's 3 o'clock in the morning and someone's walking in your backyard, like that's really interesting data. And so flag that and sample it more high resolution, and then transfer those data. And so that's, so hopefully that wasn't too deep there. So.
Thanks, Steve. So the next question from Lucas here. So do you always use the sensors already available in the plant, or do you need to include new ones there? And how do you train your models? In other words, what do you label as a failure? Are there trained models transferable from plant to plant in certain degrees? So a bunch of questions there really about the sensors. How much do I really need more? How do you train the models? And this labeling of failure, not failure, is a little bit challenging there. And the last question I think is really key is scalability. You talked about that, so.
Yeah, so those are all good ones. As far as, like I said, the anomaly detection and is unsupervised. The quality application is supervised. So it takes data from your quality logs and says, we had this quality issue, and then basically rewinds in time to the beginning of the whole process, all the way back to scrap, weather, operators, all the sensor data, and finds correlations that correlate to, we had this crack or cobbling or hopefully not caster breakout, but like whatever the issues are there, it will find the correlations in a supervised way is the way the quality one works. It's another level of sophistication. So that's the difference there. Michael, what was the other one? Help me.
Okay. They were also asking about the scaling, how transferable there, because this is definitely one that a lot of plants are interested in.
Yeah, I mean it's. I would say it is highly transferable, right? That the approaches are, understanding the different failure modes and understanding they're fairly common. It's also where our partners SMS really come in. They've provided a tremendous amount of expertise not only from a digital front, but also from a process knowledge. And obviously built many steel plants and operated many steel plants around the world. And so that expertise is really important to training the models. And so that's really important. I think there was also a question about, your current sensors, or do you need to add sensors?
That's correct.
Yeah, so I would start where there's a lot of really good data. I mean, we will tell you exactly what data we need, right? It's if someone comes in and says, what data do you have? That's a red flag, right? Someone who's implementing an AI product should come in and say, here are the data we need. So we can tell you exactly what data we need. There are some that are mandatory and some that are nice to have. And so I think it's the combination of those that we'll tell you if you have enough sensors and enough data coming off of your mill. The thing that's tragic is a lot of people throw out their data, right? They say, oh, it's expensive and we'll never use this, and so they just throw it out. That's an issue, because the training the applications is, the more historic training data you have, the better the models perform. We have done actually greenfield implementations, so the models are basically incoherent for a few months. And then it starts learning and it dials it in, and then the models just get better and better over time. So the more historical data you have, the better.
Great, Steve. Yep, we're still got a little bit last time here. This is from Somanath. And this is a really good one here, because we haven't really touched on it here on the people side. So the presentation talked about crew IDs as one element of data. This is often seen as slightly sensitive. We come across people harboring we versus they feeling, and many shop managers hesitant. Did you face similar challenges in any of the work you've done? And I'll just sort of supplement it. I have heard of real challenges of trying to implement where operations or production people were very hesitant on this big brother watching there, especially in some of these new safety AI applications there. So maybe you can comment on that people side.
Yeah, I mean, we don't do the image recognition of people. I actually have never seen that implemented well. So we don't do that area. We focus on 3 areas: asset health, product quality, and materials mix. And then we'll also do scheduling. But I think that getting operators to understand what the applications do is critically important, right? And like I said before, once you sit down with them and explain what it does and how it confirms their operators' intuition, that they generally love it. I'll give you one example of we have one application that we used to do that we really don't do anymore. It's in the box, but we don't really sell it because it's hard to make money off of it unless you can resell money to the grid. Is an energy management, energy reduction for an EAF, right? And it turns out that one of the highest correlation features for energy consumption in an EAF is whether it rained the previous week. And the operators knew that intuitively, right? The people who've been around a long time just had a gut feeling that, when my knee hurts or when there's all kinds of mud everywhere, that the EAF's going to use more energy, and you could budget accordingly. Well, the application actually could quantify that and say, yes, you were right. And in fact, here's how much more energy it is when it rained last week. And depending on how much it rained and the intensity of the rain, which allowed this customer to actually sell energy back to the grid in a predictive manner and save millions of dollars a year. So the change management and talking in the language of steel to the operators is critically important. But I think what we found is over time, they absolutely love it, and getting that adoption is really important.
Great. Well, thank you very much. We've come to the end of our time there. I promised to give everyone a few minutes to get to the next meeting. Steve, thank you very, very much on behalf of the AIST and our Digital Transformation Committee there. Appreciate all your support. Great answers, great presentation. And we look forward to using your recording. I know there's many others within my company are interested in seeing that there. So thank you very much.
All right. Thank you very much, Michael. Thanks, everybody. Have a good day. Stay safe.
Okay.
Yeah, thank you. And we hope to see you tomorrow during the part 2 of this webinar, which is by SMS Group. And on behalf of AIST, I would like to thank Noodle.ai and SMS Group for being the sponsor for this webinar today.